Hey Emily, I have your most recent instruction lesson pulled up. So we're going to kind of go through this together. Sometimes I don't actually teach the same kind of content that they're giving you here. I don't really teach a lesson about how to use technology to help with these kind of relationships. So I'm going to kind of skip through parts of this, and hopefully just kind of me talking over what he's shared will just kind of help solidify the content a little better. They're having you use a program called Desmos. I do use a lot of Desmos exercises, activities, and they do have a really great graphing calculator, which is what this lesson is kind of what it's introducing you to, is that, you know, we have graphing calculators we can hold. We can actually graph on graphs ourselves by plotting points, but we also kind of have this technology where it just does it all for us. So the first few parts of this video, or this instruction, are just getting you used to, you know, punching in expressions, and it's just showing you how things work. I'm gonna mute that because I don't want to hear him. So this then is the Desmos calculator, graphing calculator. So it has the graph over here, and as you start to input stuff on the left, it'll start to pop stuff into the graph. And so I think where I wanted to go for this was I wanted to skip ahead to one of the interactive, not this one. And I know I see these green checks here, which means you did get the right answer, but I can't tell if it was like your first attempt. I'm unable to tell if you missed it initially and then you were able to get the right answer, or even if you miss it a certain number of times, does it just give you the right answer? I'm not sure about that. So I'm going to kind of, again, skip through, because the one I wanted to get to was the one about the range, because I would guess that's where maybe we first got stuck. So when we talk about the window display, we're talking about literally how far on the X and Y axis can you see in the graph. And so it looks like it's going from -10 to +10 in the X direction. It's going from -12.9 to +12.9 in the Y direction. Why such a random number? I have no idea. Why aren't we just going -10 to 10? I guess maybe it's because the window's a little taller than it is wide. It's not a square, it's a rectangle, so maybe that's why. And all this means, that blue underline part there, that just meant, that's just telling you what the x's can go between. So when we look at this graph right now, over here on the far, I'm going to pause the video so it doesn't switch screens on me. On the far right, you can see it does go all the way to 10. So it goes to +10 and then to -10. So that's just how far your x values go. And then in the y, you can see this is that 12.9, because this is 10, 11, that's 12, so that apparently is 12.9. And then the same thing on the bottom, there's -12.9. And so what he's explaining in this part of the lesson is that sometimes you graph a line, for example, the one you can start to see at the very top of that graph, that red line here. He's basically sharing that sometimes when you put an equation on there, you can't even see it because you need to zoom out and figure out where it is on the graph. So I'm going to delete that. He's going to go ahead and keep talking. And then we get to one where it's asking you which of the following gives the best line. I do see you got the right answer, but I kind of want to talk about it. So when I go over here and I type in y equals -1, and then I put a / to give me the fraction 4, then I write x minus 13. So there's my line. And you can kind of see pretty quickly that it is way down there. So what do these max and mins mean? This means that I want the x-axis, right, this horizontal line, I want my window to start at 0 and go to 20. So I'm going to shift this, no I'm not until I switch to a pointer. I'm going to undo that work. I'm going to shift this graph over. So there's 0. This is 0 on the x. And I'm really close to 20. I didn't quite get it in there, so I maybe need to zoom. Yeah, you can zoom it in and out. So there's 0 to 20. And then the y is also going from 0 to 20. So now I actually, right now my y is going from about I don't know, 12 or 11 and a half up to about 11. So now I'm going to slide it, no, stop. Sorry. Now I'm going to slide it down. So there's 0 to 20. This is pretty sensitive. Now I need to go this way. I'm just using my screen is a touch screen, so I'm using like my fingers just to pinch the screen. Here's 0 to 20 that way. So you can see if I'm in this window, here's the actual 0 to 20 and 0 to 20 window in both directions. The graph's not even showing up. Okay, so that's what it's wanting you to do, to look at, to check. So the correct answer was negative 20 to 20. So there's negative 20 to 20. And then also negative 20 to 20. So, and this really goes a little bit higher. These go by 5s, 5, 10, 15, yeah. So really because the window is, again, taller than it is wide, that's why you can't actually zoom it out to 20 to 20, negative 20 to 20, because then you'll lose your left and rights and your x-axis. So there you go. There's a good view of the graph. That's really all this is having you do. And sometimes with Desmos, when you throw an equation in there, you have to like really zoom out really, really far to start and find out, okay, where the heck is my line? And then you find your line, and then you can start to zoom in a little bit better. It also was showing that as you travel along the line with ordered pairs, let's see, am I just clicking those? Just making dots. I saw he was dragging one. Oh, there we go. If I click and I don't let go of my click, I clicked and I'm just dragging, so I click and drag, you can find some ordered pairs, right? Remember what these ordered pairs mean. For example, that, oh, they gave you the 2 intercepts. Remember what these ordered pairs mean in x and y. So if it's negative 52, that is not a 2, that's a 0. Negative 52, 0, and 0, negative 13. It means if I plug negative 52 in right there for x, and I calculate this, I'll get 0 for y. This one means if I plug 0 in for x, and I crunch out a number here, I do the order of operations, I'll get negative 13 for y. Those are the ordered pairs on the line. Okay, so let's kind of keep skipping through this. I'm going to do closed captioning too. Characteristics. Okay, he talks about increasing and decreasing. Kind of watching the x values go up as the y values are also going up. When we read graphs or we talk about if graphs are going up or down, we're always looking from the left side of the graph to the right side of the graph, kind of like how you read a book. I understand that if I looked at this line from right to left, let's go the wrong direction, you know, it looks like, oh, we're going down, but we never go from right to left, we always go from left to right. So this graph is actually increasing. And when we talk about increasing and decreasing, we always say, as the x value increases, what does the y value do? So that's what he's checking here. So let's type this equation in. Y equals 2x minus 5. Which of the following are true? It does increase. So from left to right, we are going uphill. Crosses the x-axis at 2.5. So they had a point. The gray dot there was the x-intercept, and you can kind of hover over that. That is correct. Does it cross the y-axis at 5? Nope, there's 5 right there. It probably crosses at negative 5. Yep. As the input increases, the output decreases. No, we already said it's increasing from left to right. And that you're always going to ask yourself, as the x's increase, what do the y's do? And if the y's are increasing, then that's what we say about the line. If the y's are decreasing, then that's what we say about the line. So if you're going to say it increases from left to right, then we definitely cannot say that. The line does not enter quadrant 2 at all. So remember, I think we did talk briefly about this, and I'll just show you real quick again. This is quadrant 1. For some reason, we go counterclockwise. I never understood that, but whatever. And this is always quadrant 1. This is a really popular quadrant because both of the x and y values are positive. So a lot of times we look at graphs and that's the only quadrant we're looking at. But that is correct. It's never in this second quadrant. Oh, back to my pen. I'm trying to use this pen thing. How can technology be used to help you understand the relationship? I usually can skip the instruction. A coordinate graph can be generated by plotting ordered pairs by hand, entering an equation into a graphing calculator, using other forms of technology such as interactive tools. Yes, that's all true. So this plotting ordered pairs by hand, that's a lot of what we do in my class. We don't do much with graphing calculators, and you really don't until you get to some like higher level math. I use a ton of graphing calculators in college because it wasn't how to graph a line that I needed to know. It was get all these lines graphed and then start talking about some other things. We were trying to quickly graph lines using a graphing calculator. And I'm going to skip to the next one. Okay, so enter values for y in the table to plot points in the graph. Enter the values in the interactive table to graph the line. So -4, am I just typing these in? Yep, 2, 1, and -1. Which of the following points did not fall on the same line? Did I hit enter? Oh, I have to hit enter. Oh, that's kind of a tricky one. If you, just because it looks like blue, orange, and green do all fall on the same line, and then we get, if I were to kind of extend this, so I can see if I can draw it by hand. If we were to just, you're really just connecting the dots, trying to connect the dots, you can see that I would miss that purple one. So this is just an interactive tool. It's just another type of technology. They're just kind of going away from that Desmos calendar or calculator for a moment. Enter, and we're going to do it again. This set of values represent points on line. What's the value of A? Oh, cool. Okay, so -2, 4, I don't know what that one is, and 13. And so now you're just looking at 3 right on the x-axis. So I'm going to go over to 3, which is in between. This one goes by 2's, and they've only labeled it every 4. So be careful here. That's 2, which would make this 3. So I'm going to go up until I hit the line and figure out where did I hit the line, and that does look like it's at 7. Okay, so it's really just kind of familiarizing yourself with these online tools. You can actually go to Desmos, to the actual, to their actual website, and type in just Desmos graphing calculator, and a graphing calculator will pop up, and you can kind of mess around with it in there. But again, the things that you're doing in this lesson were things that you are already doing, but just really by hand and not using that technology. So it's just really trying to familiarize yourself with a graphing calculator online or some sort of interactive graph like this one. I hope that helps just kind of further explain. Again, I don't have any kind of information or lessons that actually go through using technology. We just don't do a whole lot with it until you get to a little bit upper level math. Algebra 2, pre-calculus, they do a lot with graphing calculators. Now, if you have any other questions, let me know. Go ahead and take the quiz when you're ready or when you feel like you're ready, and then if you need some help with that, I can go back in and look at the questions you missed. If I don't hear from you, I'll think that all is well, and still planning to meet you on Wednesday. Have a good weekend.